Hello and welcome back. This time we do a very similar thing like in the last video, but this time we are not using our photo resistor, which is changing its resistance value with light. This time we're using this little black dot thing here, which is really small, as you can see it. This thing is a so-called thermistor. This thing changes its value with temperature. Okay, so with this little thing we can measure temperature just by measuring the voltage. We will again use a voltage divider with this resistor, which changes its value according to temperature, and this resistor, and this time it's a 10 kilo ohm resistor as counterpart. Okay, that's it. Yeah. So I will again use the resistor from the fixed resistor from ground to the measurement point, measured potential. It's in. Now these little things are really tiny. Put it in. Yeah. Of course, we again have to use 5 volts here on this side, and we would have to measure from this point again to our analog input. I'll plug it in. Pim-pidim. We are online. Good. Lights are still on. This means, well, probably this is working fine. Okay. I will now download the code. I still have the same code. Watch on the serial monitor after downloading has been finished. Downloaded, finished. Here we have. Currently we are at 51%. If I'm now touching this thermistor, and you see it's changing the value. The value is going up because my hand is warmer than the room. Yeah. Now I'm releasing it again. You see the values going down. Okay, so that's not too bad. Something happens here. We can even look at it with the serial plotter. So we should see the temperature falling and rising. So we'll touch it again. Yeah, here you go. It's warming up. If I release it, it's cooling down again. This is working. Good. Yeah. But I mean, right now, there is written on the serial monitor, there is written, some raw value, some number value from the analog digital converter. Then I know the percentage and I know the volts. But what I don't know is the temperature, right? And I want to read the temperature. So we need somehow the relationship between temperature and resistance value of this little device, this little thermistor. Okay. There are several classes. First of all, change of resistance when changing the temperature is quite a common thing. Every metal makes it, and so on. Yeah, so that's usual. There is even a whole class using exactly this method to measure temperature. Yeah, let's make it this way. Exactly this method to measure temperature. Yeah, it's the temperature resistor measurement method. There's a separate video about this you can watch if you want to. Yeah, so that's a very common thing. A very often and widely used is metal as resistor, which is called platin. Yeah, platin is very commonly used in these resistors. However, metals do have one big disadvantage. Yeah, the change in resistor value is rather small. Yeah, how many ohm per degree Celsius or per degree Fahrenheit or Kelvin? Oh, Kelvin is good. Yeah, use the SE. Yeah, how many ohm per Kelvin the change rate is very low on metals. Yeah? Then there was discovered, and you should also know, the usual way is that at small temperatures the resistance is low, at high temperatures the resistance is high. That's the very normal thing, let's say. Yeah. With semiconductors, then there were elements found or things found, let's call it things, yeah. Semiconductors found which do change much more ohm by Kelvin, yeah, to have a much higher change of the value. That's good, yeah, because the sensitivity is high. Yeah, if the change of the temperature just needs to be a little, yeah, and the ohms are already changing a lot, then you have high sensitivity. That's not too a bad thing, yeah. And then there are even two classes of semiconductor materials. One is called PTC, positive temperature coefficient. This means if the temperature is rising, also the resistor value is rising. It's a PTC, positive temperature coefficient. Here we do have a so-called NTC, a negative temperature coefficient. This means the colder it gets, the more the resistance will be. Yeah? So it's exactly the opposite of normal metal thermometer. Okay. So, but why aren't we using those type of things always? Yeah. Why are we not using? I first said a very common thing is this platin. Yeah. And now I'm telling you, platin makes less sensitivity than these semiconductor materials, and there is even a material which change in the other way. Yeah, the big disadvantage of these semiconductor materials is their non-linearity. Yeah, so it makes a difference if we measure between, I don't know, around freezing, or if we measure around boiling temperature of water, of course. Yeah, it's we then have totally different sensitivity. There, metal is much better. Yeah? We can use metal in a broader range of temperature areas simply. Yeah? And the sensitivity is always constant. In the script, you do have this curve. Yeah? That's the curve of exactly this little NTC. So you see, if the temperature is getting low, the resistor value is rising. And if the temperature is getting high, the resistor value is dropping. And you see here, the gradient, the change per Kelvin is much higher than here. Yeah, so this means here the sensitivity of this thermistor is much higher than here. And that's exactly the big disadvantage. Okay, that's exactly the big disadvantage of these semiconductor materials. However, we can linearize this. Yeah? We can simply make our Arduino do the math, to calculate the degree out of it. Yeah? Also in script, you do have the correct formula. Yeah? So this is the analog read. We'll read the analog value here. Then with this we do some mathematic operations. There is a logarithm, and then we multiply and add some constants. Yeah? And suddenly we have the temperature in degrees Celsius. You see, nu is just a log. I hope all of you know the logarithm function. Yeah? In C it's just log, bracket, number, bracket close. And it's this expect floating point. Okay. So this is the thing to come from 0 to 1023, yeah, to the temperature in degrees Celsius. I will also post this little piece of code in the video description, yeah, so that you can copy and paste and do not have to type it. Your task, okay? Your task is you should do the thing here, yeah? And there should be a printout of the temperature value on the serial monitor. This is how it should look like. The printout of the current temperature you see here, and if I touch, it is going up. Okay. And if I release, it's going down again. So we do have temperature measurement with our Arduino. So long, have fun with this, good luck, and hear you next time. Thank you for listening. Goodbye.